Hello, everyone. Welcome and thank you for joining us here today for our webinar event, Eliminate Reactive Inventory Planning with Smart IP&O. My name is Hans Albright. I'm the Senior Account Executive for ATS Applied Tech Systems, APS Division. Joining me today is Pete Reynolds, VP Channel Sales with Smart Software. Pete has a background in accounting and finance, and he owned and ran a distribution company before moving into technology, specifically business intelligence and reporting, and now supply chain planning. We're also excited to have our friend Eric Sabatis with us today. Eric is a solution engineer with Smart Software. He has worked with demand planning technology like Smart for his entire career and has helped hundreds of companies, manufacturing, distribution, MRO, improve their forecasting and inventory planning over the last 14 plus years. Before we get started, let me go through a bit of housekeeping. Today's session is scheduled for 60 minutes, where we will discuss Smart IP&O's statistical forecasting, demand planning, inventory optimization, and reporting and analytics, with an emphasis on demand planning and inventory optimization. I will also briefly address how Smart's offerings complement advanced planning and scheduling. Today's session is being recorded and will be posted and made available for future viewing. We encourage you all to interact with us today. All questions are welcome. You can drop them in the chat or question pane at any time, and we will hold these questions and answer them at the end of today's session. Know that all attendees will remain anonymous to all other attendees throughout. And with that, I'd like to turn it over to Eric Sabatis to get us started on today's topic. Eric?
Perfect. Thank you so much, Hans. And we appreciate you having us here with you and to share a bit about what we do here at Smart Software and how we can complement advanced planning and scheduling. Just to cut right to the chase, the bottom line is that you can't manufacture products with material that you don't have. That perfectly optimized production schedule, for example, won't do you much good if you don't have the parts on hand in the first place. This underscores how important it is to anticipate the needs of your customers, the importance of accurately forecasting that demand. But the reality is that forecasts are inherently uncertain. And so not only is it important to forecast, it is just as critical to assess the uncertainty around that anticipated demand, so that we can risk adjust our inventory strategy accordingly. So we're going to talk about this through the lens of the platform that we develop here at Smart Software, which is called Smart IP&O, or Smart Inventory Planning and Optimization. Smart Software has been around for about 40 years or more, helping thousands of customers with their forecasting. And our current solution is a cloud-based native web platform that contains a couple integrated solutions that are purpose-built for demand planning and inventory optimization. The idea is that the platform bidirectionally integrates with your ERP system so that data is coming in on a nightly basis. And then we're able to push back the key planning parameters, notably forecasts and or inventory policies that your enterprise systems need to effectively recommend what to order and when, so that ultimately you have that inventory on hand to make what you need. Those apps, which we'll go through in this order, are Smart Demand Planner, which is really revolves around the forecasting itself, generating a statistical forecast and collaborating on it. Smart Inventory Optimization, that's where I'll expand on the uncertainty and the importance of risk adjusting our projections and our stocking policies to buffer ourselves against the risk of stockout while keeping costs in check. And then finally, there's a reporting arm of the platform, which depending on time, we might not take a big look at today, but the system does offer a variety of inventory planning reporting using the data set that we're pulling in from the ERP nightly. But all of this comes together, of course, with the goal of eliminating the reactivity that we observe frequently among our customers and prospective customers. Right? The reality is a lot of folks are forecasting using rules of thumbs and averages, and generally chasing their tails when it comes to their inventory. Our goal is to predict not just the forecasts, but also the risks and trade-offs of setting inventory policies a certain way so that we can understand their consequences ahead of time and use that information to really wield the inventory as an actual asset, as opposed to having our inventory manage us, which is something that we observe pretty frequently. So you'll notice that I've emphasized the importance of risk multiple times so far. That's a topic we'll dive pretty heavily into a bit later, but we're going to start with the forecast. Particularly in a manufacturing environment, the forecast itself serves as a key input to planning and scheduling. And getting it right fundamentally requires two core things: sound, data-driven statistical forecasting to find patterns and trends that humans simply can't, especially at scale, while at the same time needing the ability to weave in business knowledge into that forecast, right? What do you know about the business and the data and the business that the data does not show you, right? That could be big opportunities coming down the pipeline, executive strategy, pushing sales reps to sell certain product lines, feedback that you might be getting from your important accounts. The key here is that we're going to talk about statistical forecasting, but what you're going to see is the importance of a tool set and a platform where you can intuitively support a process that marries both these inputs, right? The input from the tech around the statistics and the data, and the input from you as an organization, who's of course going to know things and have a pulse on what your demand is going to be. So with that in mind, let's take a look at Smart Demand Planner and how we support some of these pieces. So I'm going to pop open Smart here, and we'll pop open an example where we're forecasting by product and by customer. All right, so let's start just by what we're looking at on the screen. Okay, on the right-hand side, we see historic demand here in the red line. Okay, this is monthly demand going back a couple years. So we can see, for example, what we've been selling to our customers over the past couple years. And then in the green line here, right now, is a statistical forecast that has been generated by Smart. Okay. One of the things we observe pretty frequently is that folks tend to rely on averages pretty heavily, right? Even if they don't call it a forecast, that's what they're treating as a forecast, looking back at the past 3, 6, 9, 12 rolling months and effectively calling that their run rate, so to speak, right? The issue with that is it does not find systematically patterns that's going to be present in a lot of data, right? So this particular product group, for example, has a pretty clear seasonal pattern. You have a busy season here in November and December, reliably year over year. You'll also notice that November tends to be ticking up year over year. And if you look at the green line, you can see that Smart is picking up on both of those patterns automatically, right? It's finding where that busy season is, and it's predicting that ongoing upward trend that we're seeing during the peak season. Okay. Broadly speaking, Smart is going to identify the ideal forecast for every single product, location, customer, etc., that we're forecasting. If I pop over to this other tab, just as an example here, you can see how the system is potentially picking a different statistical approach for every single item, right? That's important because the emphasis here is not on, say, a forecaster or a planner being savvy with the models. Rather, we can lean into the system to identify which approaches are best and where. And in turn, we as business people can focus on where do we need to change the forecast based on what we know. Okay. And so this, of course, is where that business knowledge comes into play, right? Critically, the way that the business thinks about demand is not necessarily going to sync up with how your systems want to use that anticipated demand. Right? So the classic example here is your ERP, for example, probably only cares about demand at the product location level, right? Because that's where your stuff is getting made. But the reality is your demand obviously is coming from your customers. So for example, if we sit down with the regional sales manager and they're giving me feedback on an opportunity at one of their big accounts, trying to weave that into every product location that serves that customer without taking the customer into account in the forecast would be very hard, right? And so this underscores the importance of being able to forecast hierarchically using multiple attributes, right? So in this particular example, we have this product group at the top. You saw me break this down to a product level as we looked at the different forecast models that were being selected. And then in this example, we can break it down further, down to the stockable location, and then eventually all the way down to the customer level. Okay? Notably here, we don't necessarily need to look at the forecast product by customer, right? The regional sales manager, for example, might be thinking about this purely around the context of what are we selling to, say, Walmart as a whole, as opposed to what are we selling for every specific SKU to Walmart. To handle that, we can effectively pivot this hierarchy on the fly. So for example, here, I'm going to change what's called the roll-up so that we're viewing this forecast from a customer perspective, right? If I click OK, it's going to pop up another window, still showing us all the same stuff. So this is all live linked between the product-centric view and now a customer-centric view. But notice here, we're now able to see the history and the forecast for our key accounts as a whole. And if you look over to the left back at that hierarchy, notice that we have a couple key accounts that we've isolated, but we've grouped the rest into this all other customers group. Right? So that's important because we might have hundreds of customers. Many of them might be pretty small mom and pop type shops where we still need to forecast their demand. But from a process perspective, I probably don't want to get bogged down in all these onesie twosie sales that are going off there. And so this enables me to focus more on the accounts that might be driving the bulk of our revenue, for example. Okay. Now, if I pop over to this forecast tab, this means that now I can talk to that regional sales manager and pull in their input at the level that matters to them. So just so we can see what happens here, I'll expand the customer. So here you can see those same product groups we saw before. And if they tell me that they're anticipating a, say, 10% bump in May, say due to a price special we're running, or maybe they're opening up some new locations, we can pop in that adjustment. And if you watch the forecasts inside this customer, notice how they proportionally adjust relative to the change that we've made to the customer as a whole. Okay. Of course, if we do have insights into individual groups or products, for example, we can still come down to these lower levels and say, well, I know, we've quoted them for this particular SKU 5 times what we normally sell. I can still come in here and build in those changes as well. Okay. Now, if I head back to the other roll-up, so to speak, so head back to the one that's organized by product, and I click up to the product level. Actually, let's go all the way up to the product level up here. Notice in the green line that those changes that we were making by customer have reconciled to the product level regardless of customer, right? Once again, this is important because it enables us to bring in the stakeholders that think about the demand a certain way, incorporate their feedback, but then ultimately automatically reconcile it back to the way that our systems are going to help us plan for that demand and ultimately plan for the inventory that we need to plan for that demand. Right. And so once we have this at this product location level, right, we've run through this process of a statistical forecast, we've tweaked it, we can then send this forecast off to our ERP system with the button press. Right? The ERP system will be responsible for then delegating that forecast out to APS so we can ensure that it is seeing not just our firm demand, but also the forecasted demand that we want to anticipate. And it's doing that automatically to the product location level, even if we're choosing to roll it up by group, break it out by customer, and so on in a tool set like this. And so this is the basic chronology of a forecast cycle. Right? We generate a statistical forecast. We weave in feedback from sales, customers, etc. And then we push the forecast back into ERP. Now, as we forecast, of course, we want to be doing this on a routine basis, right? We should be forecasting on a rolling basis. For many organizations, that means forecasting monthly and updating that forecast in ERP monthly by way of a review. It could be weekly, but realistically, to improve over time, we need to be tracking our performance and tracking the accuracy of those forecasts. And so that's the other piece that the system accommodates for us. Once again, in spreadsheets, you'd have to be storing those forecasts, not just every month over time, but also potentially storing multiple forecasts for every month, right? I might want to be tracking how my statistical forecast is doing versus how my sales forecast is doing. Many of our clients get forecasts from their customers. They might want to track how those forecasts are performing as well. And so the system will automatically snapshot these previous forecasts over time so we can go back and compare them to actuals. So if I pull up, I'm going to head up to a group level here in this case. In the black, I've pulled up a statistical forecast from the past. And I'm also now pulling up a customer forecast we've received from the past. And if I zoom in, here you can see the ingredients that we have to track accuracy. And just looking at it visually, I can very clearly see that we've overshot this forecast, generally speaking, over the past 2 months. But our customer forecast here in the orange has actually been a slight improvement over the statistical forecast, right? That's valuable. I might want to lean into what my customer is saying for some of these forecasts, or what my customer is telling my reps for these products. But that might not always be the case, right? If I jump to a different group, here's an example where my customer forecast is a bit more all over the place, right? The actuals are here on the bottom. Here's my statistical forecast, which has been pretty close to what has actually happened. But meanwhile, if I had leaned into my customer forecast for March, we would have been way off, right? They would have way overshot what they actually bought. And so in this way, right, there's a variety of reports to track this accuracy systematically, understand our average errors over time, understand our errors by different forecasts, so that we can use that data to incrementally improve how we're forecasting. All right, so I'm going to kick back to the slides here and open this one up. So the forecast is important, and obviously we should strive for a good number that the organization agrees on, but there's a cliche in forecasting that the forecast is always wrong. Right? The reality is, in most organizations, particularly for those whose boots are on the ground, so to speak, salespeople, buyers, and the like, they're generally going to remember those stockouts much more vividly than any of those overestimates. Right? And so the pattern tends to be a stock out, sales pressures the purchasing team to buy more stuff. And even though this doesn't happen all at the same time, one order at a time, inventory creeps up and up and up. And eventually, someone who's crunching the numbers starts to notice, right? And alarm bells go off. We're writing off way too much inventory. And then suddenly there's a directive that we need to cut inventory, right? All at the same time, right? But how do we do that without introducing stock out risks and starting the cycle all over again? And who's caught in the middle but the supply chain team, trying to balance these two sides. Realistically, the only way to completely eliminate stockouts for all your product is to spend a lot of money, right? And we can't do that. Even besides the direct costs of excess inventory, there are large opportunity costs to the business to tying up all that capital. And hence the importance of treating inventory management as risk management. Once again, forecasts are imperfect. And so what we need to do is predict stock out risk, buffer ourselves, buffer the forecasts against that risk while weighing the costs. It's notable that this is a slightly different exercise than the forecasting that we just saw, right? That forecast is an important ingredient to assessing stock out risk. But whereas the forecast is just a single number, predicting risk is really about predicting many possible outcomes and assessing their likelihoods, using that data, weighing it against the costs to come up with proper risk-adjusted strategies where we're taking on acceptable risk while keeping those costs in check. Right? This is how we will maximize, how we want to maximize return on that inventory investment, which realistically lies somewhere in that balance of acceptable stockout risk versus the cost, especially when you apply it at a large scale. So the astute observer, so to speak, may pick up on the fact that when we talk about risk adjustment, what we're really talking about is safety stock, fundamentally. Right? There are different kinds of replenishment policies, mins and maxes, reorder points and order quantities, up to strategies, forecasts plus safety stock. But the core idea of those strategies is all the same. Right? How do we set a threshold systematically, product by product, location by location, that will serve as triggers for when we need to get more stuff, while leaving that safety stock to eat into as we wait to get more. What we observe the most here at Smart, particularly when folks first approach us, is an overabundance of rule of thumb and wait and see approaches. Right? So it'll look something like this typically. We're going to look at what our average demand is. I talked about averages earlier and where those fall down on forecasting. But once again, when it comes to safety stock and reorder points, folks routinely fall back on looking at average demand. We take our supplier's word on the lead time, or we take an average of maybe the last couple POs versus receipts to see the dates. And then we double that demand over the lead time as our safety stock, or maybe we triple it, or we quadruple it. Right? We're holding 4 weeks of supply or 8 weeks of supply, or whatever rule of thumb that we come up with. Right? And we might even come up with a bunch of options around how many periods of supply we want to hold on to. We might know the quantities. We might even go so far as to calculate the costs. But with just this information, it's impossible to know until after the fact whether that rule of thumb was enough to keep on hand, or whether it was too much, right? And as we talked about, we generally aren't going to take a keen eye to those ones that are too much until it's too late. Those often sit rotting in the ERP system for a long time. And then meanwhile, inventories often will creep up because we only notice the not enoughs, right? And those, of course, in and of themselves might be ticking time bombs. We might have a lot on hand right now, but because we're waiting for the ERP system to tell us when to order, if that number is too low and it hasn't been touched in a while, then we're going to run out. But what if we knew ahead of time what our stockout risks were? Right? So here we present those predicted stockout risks as a predicted service level. So service level being a measurement of our ability to meet that customer demand. First off, by predicting this ahead of time, it's going to tell us and identify ahead of time which policies are risky, right? Things that are way off the chart based on these predictions will illuminate where do we need to boost those reorder points before it's too late. And similarly, on the other end of the spectrum, it'll expose obvious opportunities where we can afford to push orders out and potentially order less while still being able to meet our demand proactively. But secondly, it enables us to arbitrate decisions around the inventory strategically with costs in mind, right? That's really the critical piece of this trade-off data. Because when you get into this middle ground, there isn't necessarily a perfect answer. Right? We can make some assumptions about costs and maybe optimize which number is best. The platform actually does have a way to do that. But realistically, the risk we're willing to take on versus the investment, right? That's an organizational decision. And you can't make that decision if you don't have this information, right? Otherwise, you're making the decision blindly. So let's take a look at a concrete example of this over on the platform as well. All right, so we're over here in Smart Inventory Optimization now. And if you turn your attention down here to this summary view, a bit of background. As we saw in Demand Planner, right, one piece of information that the system is pulling in is our historic demand. And we're generating forecasts based on that. The system's also pulling in information related to lead time, right? That's the other critical ingredient to setting a policy at an accurate level. What we also have at any given time are the policies that are currently set in the ERP system, right? At any given time in your ERP system, those policies are going to govern when those orders are triggered. And so by having a digital clone, so to speak, of those policies, along with the demand and the lead time data, we can subsequently stress test those policies to make these predictions around stockout risk and cost. So what this live scenario tells us is right now, based on the most recent demand conditions and the most recent lead times, what kind of stockout risk are we exposing ourselves to? And realistically, how much inventory are we likely to be sitting on in the near future? Now, we can leverage this same analysis to run what-if scenarios in real time. Okay. So, for example, let's say I want to analyze my most important products first. Right? We could do this across all items if we want, but realistically, for example, we might classify our data by ABC category, right? Classic 80-20 rule kind of stuff where I want to ensure the policies are good for my biggest money makers. Smart, for example, has a way of building out those classifications dynamically. And so in this case, I'm going to isolate these high volume, high frequency items so that we can build out some policies for these fast movers. Now the summary is just showing us the analysis for these items. And if I scroll down, here we can see the individual product and location level detail. And so here are all the products that we're stocking and setting policy for, safety stock for. Here are all the stockable locations where we're keeping this material. And over to the right, you can see the individual item detail, right? In this example, we're running on a min-max policy. The trigger is the min, and when that triggers in our system of record, it would tell us to order up to the max. We have the lead times, but most importantly, you can see that we have individual service level predictions for every product. So in other words, even though the average predicted service level is a little under 86%, behind that number is potentially a spread of different predicted stockout risks. So you can see here where my mouse is, some products were predicted to be exposed to a significant amount of risk. If we wait till ERP tells us to order at 66, there's about a 2/3 chance that we're going to run out while we're waiting to get more. That recommendation would have come too late. And on the other end of the spectrum, some of these predictions are quite high. This one's at 99%. We're almost always going to be covered given the current policy. And if I click the column, we can sort it, right? So notice how powerful this analysis is in the sense that it, at scale, can identify all of these at-risk items, both on the low end, right? Where are we at risk for stock out? And where do we need to proactively boost our stock position? And on the other end, right, we can see how we can sweep up all these items that are predicted at very high service levels. Where are there opportunities to reduce inventory without taking on too much risk? Rather than doing it one by one, we can deploy policy and strategy across many items all at once. So if I head over to this drivers tab, for example, we can deploy service level targets. Here, what I'm going to start by doing is saying, I'm going to target a 99% service level for all of these fast moving products, right? What's this going to do? Any items that are currently predicted at less than 99, it's going to boost those reorder points based on the demand, based on the forecasts, based on the lead times and the volatility in the data to achieve that level. And on the other end of the spectrum, some of these are going to come down, right? You can't get better than 100%. And so some of these could be egregiously overstocked, right? Policies that have been sitting in ERP for months or years on end without being touched. And so there might be tremendous opportunities to reduce those mins. And so we click the button. In a few seconds, that will calibrate all of those reorder points. And now if I head back to the summary, we can see the net result of that change as a what if scenario virtually instantly. So in this case, right, we've effectively eliminated stock out risk here. And in this case, also achieved a small inventory reduction, right? Just a few percentages of what our overall inventory was, but we're able to do that once again because it's identifying where are we at risk of stock out and boosting those, while simultaneously coming from the other side and exposing where we have the opportunity to find some reductions. Now let's pause here for a second though, right? This is a pretty modest reduction. If our directive was to reduce inventory, say by 10% or 15 or 20%, that is not an uncommon directive coming off of, the COVID years, for example. This wouldn't be nearly enough, right? And of course, a 99% service level target for many industries is going to be considered pretty dang high, right? And this underscores the importance of the trade-off data and the importance of these what-if scenarios, right? Depending on our objectives, we can make informed decisions on how we want to wield our inventory. So what I'm going to do here is first, I'm going to save off the what-if scenario we just ran, and I'm going to call it maximize service. Okay, that way we can call it up later for comparison's sake. Now I'm going to go in and I'm going to change the service level target, say to 95%. Right? Maybe our current service levels that we're actually observing are in the 90 range. Right? Once again, not uncommon for many manufacturers and distributors to have service levels in the 80 to 90%, depending on how they're measured. So let's say 95 would still be a solid improvement over where we are now. We'll click the button, and once again, we get instant feedback on where we could be should we choose to accept that slightly lower target. And you can see, of course, our service level has dropped by a bit, right? But in this case, a drastic change in the inventory value, right? What's notable here, and one way to think about this, is it might only seem like a few percentage points. Let's pull up that other what-if scenario for comparison's sake while we're talking here. But realistically, what this means is we've effectively doubled or tripled our stock out risk, right? Think about this. If we had 1,000 items that we were considering, this might mean 50 items of those 1,000 would stock out, jumping up to several hundred items stocking out, right? So it's not a trivial difference, but the trade-off, of course, in this case is hundreds of thousands of dollars. And this is why this information is so important, because without it, you can't arbitrate decisions on what kind of stock out risk you're willing to take on and how to truly allocate that capital in the best way possible. Now, I've just talked about this in the context of fast movers, but of course, not all products are created equal, even irrespective of velocity, etc. So if I scroll down here for a moment and I just head over to this attributes tab, realistically, you might slice and dice and analyze your inventory policies by any number of different attributes, right? So for example, we often set inventory policy at multiple levels of your bill of material. And you might want to set very high service levels for common critical components that you use across many of your finished goods, right? That might be a no-brainer to accept the high cost of targeting a 99% service level, for example, because it's non-optional to run out. On the other hand, you might be willing to keep inventory a bit lower, maybe on specialty items or accessories that some of your customers are willing to wait for if you happen to run out. Okay, these are the types of decisions that you're able to weave in using service level targets when you have analysis like this and when you have the ability to really wield what your inventory might look like ahead of time, once again, as opposed to chasing what those mins should be on a part-by-part basis as they come up for order. Finally, we can set our goal scenario, right? We're generating these what-if scenarios. We can set our goal and automatically push these results back into the ERP system. One thing that I've said offhandedly a couple times is that these policies often will sit in ERP for a long time, totally left untouched. It's not actually uncommon for us to talk to folks who say, yeah, we set it and forget it when we implemented our ERP. And after that, we've never really systematically went through and changed them. All sorts of reasons why that's a bad thing. even inventory misallocation aside, it also tends to foster a mistrust in your systems when no one trusts the suggestions. But that, of course, underscores the importance of being able to update them and calibrate them more frequently. Okay. And so, just from a technical perspective, having the ability to push back updates en masse to your system without having to run cumbersome analysis and uploads in Excel, for example, could go a long way in ensuring that you're keeping up with trends and changes in your demand. Now, popping back to the slides here for a moment, speaking of updating them frequently, kind of like the forecasting, where I describe it as commonly a rolling process, right? And that's what's recommended. Unfortunately, safety stock and reorder policies are not often treated the same way, as I just finished saying. But they should be, because the reality is that demand is changing over time. Lead times are changing over time. Your priorities might change over time, right? What was once a critical product that you always wanted to have in stock, might not be anymore. And there might be a different product line where we're trying to corner the market and dominate. And that's where we want to be allocating our inventory dollars. And so periodically recalibrating all the policies is very important, but it's very difficult to do without a tool set. A tool like this supports that by, as you saw, deploying those targets en masse, but also allowing us to set those targets and have the system auto-calibrate back up to where we need to be to continuously meet those targets or drop them down, if applicable, as those numbers change. And then we, in turn, would focus on the exceptions when it comes to the policies, right? Where the policy is changing significantly. The other workflow here, though, of course, is there will always be, speaking of exceptions, times when a recommendation pops up, or inevitably when we do run out of something, right? Bear in mind that even if we target a 99% service level, that by definition says that among, say, 1,000 items, we should expect to run out of 10 of them. So when we do run out of them, the tool gives us the analytics to go in and do a postmortem, right? What happened? And take a look at, was our lead time assumption wrong? Was there a change in demand that we missed or weren't aware of? Or did everything go according to plan? We had 1,000 products and we ran out of 10 of them, and that's just the way it is, right? But the system allows us to pull up those products and run that analysis to make changes. As a quick last example there, since we do, I think, have enough time for this, if I pop over here, one thing that the system does is it'll track actual lead times. So for example, here in this column, we'll also pull in POs to suppliers along with their respective receipts. And if you measure the delta on the dates between those two transactions, you can get a pretty quick handle on how long realistically does it take for my suppliers to deliver to me. Those listening, this might be stating the obvious. For a lot of people, they have a gut feeling that the assumed lead times are not the real ones, or perhaps there's a static field sitting in ERP that they know is inaccurate. But oftentimes the level of inaccuracy is opaque, right? And what our actual lead times are is often opaque. This column shows us, for example, the average lead time over X number of receipts, right? So 70 days over 16 receipts, 25 days over 11 receipts, 11 days over 19 receipts. This number can have a significant impact on what our reorder policies are, right? If we're planning on a 30-day lead time, but our actual lead time is 70, we're going to way underestimate demand, right? Or if our actual lead time is 11, but we're planning for a 30-day lead time, then we're carrying way too much, right? Because we could be replenishing much quicker. And if I pop over here, you can see some of these massive differences, right? In this case, let's turn off that other what if scenario here just for a moment to keep things a bit simple. In this case, the actual lead time was 11 days, but perhaps we have a holdover from the COVID days here, right? Where we're planning on a 120-day lead time. Our min can be 47, given a 95% service level and a 120-day lead time. But what could it be if we were using that actual lead time of under 2 weeks? Right now it's 47. We recalculate. And you can see what a difference it makes, right? We can afford to go down to 6 if we were capturing the correct data to drive that decision. Okay, so just another example of the importance of getting the data right, particularly when it comes to lead time, and particularly when it comes to recalibrating policies when we identify, say, stockouts and one-offs that we want to investigate. All right. All right, so as we head toward the end here, here's just as for context, a sampling of some of our customers who have identified and chosen our solution to help them with demand planning, help them with inventory optimization. Since for these folks, their real value was placed on this strategic element of the planning, right? Being able to wield inventory at a large scale and being able to make million-dollar decisions by way of those policies. Notably, not written here on the slide, but notably, our patented technology that drives those service level predictions is also specifically tailored to handle very intermittent demand. Intermittent being very spiky, lumpy, stereotypically unpredictable demand. Those types of items using traditional methods, we can often overreact, right? We see a spike and we start ordering a lot. We see a couple periods with no demand at all and we bottom out our inventory. That's not the way that you want to handle those items. The reality is there are demand for those items. We just don't know when they're going to hit. And our system has patented technology to help you plan for those items. I say this because a number of these customers on this slide chose us for that exact reason. So if you deal with a lot of intermittent demand above and beyond the what if scenarios, that can be a critical component to getting things right. So with all that said, just the bottom line here and to kind of summarize. First, a good forecast combines that objective statistical baseline with business knowledge, right? At the end of the day, we need to capture patterns like trend and seasonality at a large scale. But at the same time, we need to weave in what we know about what our customers are up to. And the key there is to enable stakeholders to do it at the levels that make sense to them. If we want to get feedback from sales, it's going to be real hard to do that if I'm just giving them a list of product level or product location level forecasts. But forecasts are imperfect. And so our position is to embrace that uncertainty, right? Don't ignore it, embrace it, assess it, and use it to your advantage so that you can shape your inventory based on that risk assessment. The simple reality is you're never going to eliminate that uncertainty in the forecast. So your only other option realistically is to predict that too. And like I said, use it to your advantage. And the net result of that, the net result of properly risk adjusting how you're carrying your inventory is what will ultimately maximize that return on your inventory investment, right? You'd never place a bet at a casino, for example, or I hope you wouldn't, without knowing the odds ahead of time, right? So why would you do that with your inventory? If you're doing that, then you're planning blindly. All right, so I want to thank everyone for listening. And at this point, Hans, I'm going to pass it back to you, and then we'll take some questions.
Okay, thanks, Eric. That was really great. So I'm going to take a few minutes before we get to questions today to introduce you to advanced planning and scheduling, or what we casually refer to as APS. So as a former production scheduler, I forget, it's easy for me to forget that not everyone knows exactly what production scheduling is. So I thought I'd just take a few minutes and explain that. So when we talk about production scheduling, it's bringing together this process of planning and timing your manufacturing operations, all the different operations that you may have, to maximize efficiency. And in order to do this, this system includes what products are going to be manufactured. This is generally information that we're taking down from the ERP system. When will the products be made? Typically, this is all driven by the due dates of those products when we promise to deliver them to a customer or when we intend to have them in stock. And where will the products be made? Is that going to be whether it's individual manufacturing lines or even which facility in multi-facility operations, where will those products be made? And who's going to do the work, right? So we have people with different skill levels, capable of running different pieces of equipment. And even within the skill level to run a piece of equipment, there are different levels of skill within that. So we want to have the people identified who's going to do the work, but also we want to very carefully take into consideration what those people are capable of doing, not just if they're available. And then finally, we need to know what materials are going to be used to make this. So when you bring all this together, it is, I like to think of it as the beating heart of any smooth running manufacturing operation. So this image shows nicely how APS integrates with multiple different systems to bring the most accurate and up-to-date information into the schedule to create a schedule that reflects reality on the shop floor. So if you look at this image, in the center, you see the scheduling, right? The APS sits in the middle, and it's taking information from the ERP system, static information, such as bills of materials, routings, product information, but also transactional information as well. So now we're getting into orders, purchase orders, sales orders. So all of the supply and demand, it's pulling that from the ERP system and working that into a schedule. But it's also taking inputs from other systems as well, whether it's an MES system, whether it is a preventative maintenance system, or whether it's a system like we see today, where it's inventory management and optimization, right? That kind of a thing. So it brings all of this into the schedule, comes up with the best schedule, taking into consideration real world situation, what's going on, what tooling is available, what operators and what skill sets are available. Do we have enough space for things to move through that need to cure for a while or something like that? So all of these things are taken into consideration, and then the schedule is set, and then all this information is distributed back out to the informations that delivered that information so that they can update their records as well. So like I said, it is the beating heart of any smooth running operation. So the product that our company, ATS Applied Tech Systems, the APS division, the product that we use or that we promote is OpCenter APS. This is a product that is owned by Siemens Corporation. Some of you may know it from the past as Preactor Advanced Planning and Scheduling. Well, Siemens Corporation brought Preactor in 2013. They have rebranded it, but it is still the same product that you see on the left-hand side of this screen. It has the largest install base of any independent planning and scheduling system out there. Thousands upon thousands of licenses have been delivered to thousands of companies. And here in North America, there are over 350 at this point. This says nearly, but there are over 350 companies that are using this in North America. And of those companies using this in North America, our company has about 80% of those people in our base. So our company has been doing advanced planning and scheduling and nothing else for 25 years. And our team has a skill level, an average skill level of about 15 years with the product. So we have a very strong team who understand advanced planning and scheduling. And as you can see, the product itself is, you can see that it's well adopted when you look at some of the global users of OpCenter APS. But what's really notable that I like to point out here as well is the different industries that it's fitting into. You see, automotive, and then at the other end, you see food and beverage, things like that, right? So this is the same product that can be configured to fit tightly every different company's unique scheduling rules and unique scheduling situations that they have. And the product does this without ever having to do any sort of changes to the source code of the product. It delivers a tool set to configure and to design and configure to your unique situation. It's a very, very powerful tool. The tool itself is made up of scheduling and planning. The planning, we probably only have about 5 to 10% of our customers actually use the planning portion of this. It is a longer term, more abstract kind of tool where you plan into buckets. It is also very useful for capacity planning out into the future. But the scheduling is the most commonly deployed. And as I pointed out before, we can integrate to any number of systems to bring that information in and to deliver the most accurate picture of what's really happening on your shop floor, while increasing the efficiencies, increasing your on-time deliveries, reducing waste. And these are the types of benefits that our customers often see. So it's a very powerful tool. And if you have any questions about that, we would certainly love to talk to you. Okay, with that, I think we are ready to take on some questions that we see coming in on the chat. So I will go ahead and do that and share the questions. And I'll take ones for me, and I'll share the ones with for Eric with him. Okay, first one I see here is, can I break down my forecast by sales channel? So Eric?
Yeah, so it's a good question. The examples that we looked at were broken out by customer, rolled up by product group, and of course also product location. But the system supports flexible hierarchies. There's no limit to the number of levels or what those levels are. So you can easily break it out by sales channel, e-commerce, retail, wholesale, etc., or any other dimension or attribute that might be important for how you want to do your planning. Once again, I know I said this a bunch of times during the presentation, but regardless of those levels, right, which could be sales channel or any other number of them, it will still automatically export out of SMART at the level required by your ERP, for example, which once again is usually product location, product site, or its equivalent.
Okay, great. Okay, let's see. Next question. The lead time fields we have are inaccurate. Nobody updates them. Okay, I've heard this before. How would you handle this?
Yep. So I did touch on this briefly, but it was pretty quick. So long story short, we pull in a lot of data from the system of record. Among that data is going to be POs to suppliers and their respective receipts, right? So it's two transactions. Both will have dates on them. And if you compare them, naturally, you're going to be able to measure what your actual observed lead times are. So with that data, the example I showed very quickly at the tail end of the walkthrough showed an average lead time, right? So that's certainly one way to calculate a dynamic actual lead time that is not tied to like a static field in the ERP. But we do have the ability to build more sophisticated calculations for how to do it dynamically. So it usually doesn't need to be anything crazy, but stuff like I want to drop the outliers. Sometimes we've air freighted this part and I don't want to skew the lead time when we air freight it. Or maybe we want to weight it, so that we're weighing the recent receipts more heavily than the old ones. Our next generation of products of the platform as well will also, if for those that want it, will factor in the lead time uncertainty into the service level predictions as well, right? So I didn't get into the math a whole lot, but our system is really based off of probabilistic simulations where we're simulating a possible future demand quantity over the lead time thousands of times. So in addition to simulating out possible demand quantities, the system will also grab a random lead time from the hat, so to speak. And so naturally, when you have a lot of lead time variability, it'll factor that in versus the more stable ones.
Okay. Excellent. Okay. One more for you. Another one just came in, Eric. what kind of inventory reductions do your customers tend to see?
Yeah. So the classic ROI question. So the kind of stock answer here is it's not uncommon for our customers to see 5 to 10% reductions or more, and along with either maintaining or boosting their service levels, right? That's sort of the very cookie cutter stock line. But I always qualify it pretty quickly, because I'm personally very skeptical of anyone who just throws out ROI numbers without knowing anything about, a customer or the data. So the benefits really depend on the organization. So just as a flip side to the reduction, one of our make to order manufacturing customers who spoke on our behalf at a conference last year, they actually increased their inventory levels. Their big issue was that they had, literally millions of dollars of highly configured, expensive stock sitting on their shop floor that they were unable to ship because they were missing relatively inexpensive components, right? Those components weren't there. They could ship it out and realize that cash and invoice their customers, but they couldn't get it out because they were waiting for, at some times, like literally like nuts and bolts that they needed. And so for them, they actually increased inventory, notably in strategic places. And so their net benefit was really less around inventory reduction, but really a massively improved cash flow by being able to get those expensive make-to-order products to their customers faster. So it does depend, but just in light of all of that, I usually just try to really underscore the importance of the control over your inventory, right? You can't make decisions around where you need to boost stock, where you can afford reductions, et cetera, if you don't know ahead of time the risk and the cost that you're taking on in the first place. And to that end too, you have to maintain your inventory levels over time. This is not just a one-time exercise. So stock answer is that sort of 5-10%, but realistically, it's all about not planning blindly, and that in turn will trickle down to maximizing that investment.
Okay, well, that makes sense. Okay, hey, I got a question here for me. Does OpCenter APS give the scheduler visibility into inventory? The short answer to that is yes. It does. And I guess the longer question, or the longer answer to that, is that in the same way that I talked about the schedule being realistic and being tempered by conditions on the shop floor, what tools are available, how much space do we have, what operators and what skill levels are available, all of those things are very important. But you also have to have your materials at the right place at the right time. And so you do have that visibility. You have the visibility of the inventory tied to the operation levels. So for instance, if you're doing a job that is going to take, you have to go through 20 different operations, and you have materials that are introduced all along at multiple different points in those operations, the system does not make you wait for all of the materials to arrive before you can go ahead and start production, but rather it's pegged to the individual operations so that you can be as lean as possible with your inventory as it comes in. Your schedule has been coordinated with those receipts for purchase orders or for inventory that will be available. And it's a very lean process where you are able to see the inventory and schedule with confidence that it will never tell you to start an operation when you do not have the inventory available. Okay, it looks like we have one last question, and that's for Eric. How long does SMART take to implement?
Yeah, so we do have it's worth noting that we have a couple tiers of the solution, so to speak, right? Where the idea is there is a basic tier that has a fixed cost implementation where the implementation itself is very well defined. And that one, in theory, it could be up and running in a matter of days, maybe weeks, depending on availability of resources. For the full platform, as you saw, Smart Inventory Planning and Optimization, average implementation is somewhere in the vicinity of 3 to 4 months. The reason being, we spend a good deal of time getting the data right. There's a pretty rigorous process of discovery around defining what your demand is, I have yet to encounter someone who, once they really get their hands into their demand, don't immediately start unearthing issues, right? Well, those transactions are wrong. I don't want to include those transactions in the demand signal. We should really be using that date field instead of this date field, right? None of it's rocket science, but it takes time to comb through, and it's critical because in a system that produces answers, it's a classic garbage in, garbage out. Right? And we talked about lead time in response to an earlier question, and same deal there. So that process is the most important part. It does take a couple weeks, and once that's defined, then you really kind of get off and running. But to that end, generally about 3 to 4 months until you go live.
Okay. All right. Well, we've gone through all the questions that have been entered. So I believe that wraps up our session today. We appreciate all of your questions. Hope you found today's session full of valuable information. We thank you for joining us here today. We encourage you to take advantage of the information on your screen now. Both of our companies have websites. We have social media outlets that are full of quality content, providing you additional solution information, project methodologies, case studies, videos. And then if you have further questions or requests, feel free to reach out to us directly at the email addresses or phone numbers you see there. We would certainly enjoy the opportunity to speak with you. Once again, thank you so much for joining us today.